Boy, do I have something to show y'all today. We're going to talk about this little part right here, this b squared minus 4ac. It's got a fancy name. It's called the discriminant. Now, I often call it the determinant by mistake. So if I say determinant, I probably mean discriminant, all right? So the discriminant is that part that you're square rooting in the quadratic formula, and it helps you determine what they call the nature of the solutions. It helps you determine whether they are imaginary or complex solutions. It tells you how many solutions there will be. It tells you quite a bit about it. So there's three basic cases. The first case we're going to look at is when the discriminant is less than 0. All right. So we're not actually going to solve this thing. We're just going to do this part, the b squared minus 4ac. All right. So b squared is going to be negative 4 squared minus 4 times a, which is 3, times c, which is 2. All right. Negative 4 squared is 16 minus, because there's no other negatives, 4 times 3 is 12. 12 times 2 is 24. All right, so we get 16 minus 24, and that is negative 8. That is our discriminant. All right, notice that's less than 0. So when the discriminant is less than 0, this means that you're going to have this. All right, I guess I'll put it down here. This means there are two complex roots or solutions. Roots is another name for x-intercepts. Basically, if you were to graph this, it wouldn't actually cross the x-axis, so it doesn't have any x-intercepts, or roots is what they would say, but we're just going to call them solutions. There are two imaginary solutions. And the reason that is because if negative 8 is under the square root, well, that means you're taking the square root of a negative, and that's how you get imaginary solutions. All right, next one. We're going to see what this is. It's a mystery. All right, so if the discriminant is less than 0, you get two complex solutions. B squared, so we're just going to do that part right there, and that's going to tell us about the solutions. So b squared minus 4ac. 11 squared is 121. Ooh, I don't know 16 times 6. But I do know 24. Or do I know that? I think this is a mistake. All right, 11 squared minus 4 times 6. Yeah, this is equal to 25. Oh, I know what this is. All right, we'll just call it fill in the blanks. All right, this is going to equal 25. So when the discriminant is positive, this is there's actually two meanings to this. I'm just going to change this so that its discriminant is greater than 0, because 25 is greater than 0. When the discriminant is greater than 0, this means there are two real solutions. All right, we're going to talk more about this here in a little bit, but if it's positive, if it's bigger than 0, that means you're going to have two real solutions, because when you square root this, which is part of the quadratic formula, after you square root it, you're going to plus or minus it with a number, and then you're going to divide that by another number, and that means it is going to be a real number. All right. So far, I guess the only way we can get imaginary numbers is if we square root a negative. So in this case, what this means graphically is that there are two actual x-intercepts. Like if you were to look at the graph of this, it might look something like that, where it crosses twice. What is this one supposed to be? I might have to pause the video and make up another example because let me see here. So b is a 1. So b squared is 1 squared minus 4 times a, which is 1, times c. Well, this is going to be imaginary again. 1 squared is 1. 4 times 7 is 28. So you end up with negative 27. I think that I made a mistake in my examples. So I'm going to pause the video and go back over and make another example real quick. But this one, because it's negative, it would have 2 imaginary solutions or complex solutions. All right, I just made one real quick. This is my final case, and it's when the discriminant is equal to 0, okay? So we already talked about these two. We looked at when it's negative, when the discriminant's less than 0. We said when it's positive, you get 2 real solutions. The last one here, all right, b squared minus 4ac. That's the discriminant. So b squared is negative 12 squared minus 4 times a times c. All right, negative 12 squared is negative 12 times negative 12 minus, well, 4 times 4 is 16 times 9. That's also 144. And so what you get is 0. So if you square root, negative b, I'm just going to write it out so you see what I mean here. 0, that's the discriminant. So if you do this, if you do the quadratic formula to it, you're actually only going to get one solution. Normally it might be an actual number here besides 0. So you get a plus of that and you get a minus of that. So that's how you usually get 2 answers. But here, if you add 0 or you take away 0, it doesn't change anything. So really, you only get the one answer. You only get the one solution, not 2. So those are the 3 cases for the discriminant. All right, the discriminant is b squared minus 4ac. If the discriminant is equal to 0, there's one real solution. If the discriminant is negative, anything over here, then you get 2 complex solutions. And if the discriminant is positive, there's always going to be 2 real solutions. Oh yeah, forgot to mention, on the one where it's equal to 0, because there's one real solution, there's only going to be one real root. So those are the ones that kind of look like this, where they're just barely touching the x-axis. They're tangent to it. All right, that's what happens in those. So now I want to mention real quick, you can cut the video off here if you want to, but when the discriminant is positive, there are 2 real solutions, but there's 2 possibilities here, okay? Those real solutions, they could either be rational or they could be irrational. Those are the only 2 possible cases. So when the discriminant, this part, if it's a perfect square, so like earlier we saw one that was 25. If it was 16 or 81, when you square root a perfect square, you get a whole number. You get a rational whole number. All right. So when it's rational, what am I thinking here? Sorry. Oh, you get a rational, 2 real rational solutions when the discriminant is a perfect square, like 81 or 64, any of those. All right. These are nice. It's nice when this happens because that also means that the quadratic that you were originally looking at that quadratic is factorable. Remember, factorable just means, let's see, minus 2. Yeah, factorable means that it can be rewritten in terms of multiplication. All right, so it could be x minus 2, x plus 1 in this case. And if you were to find the discriminant of this, it would be a perfect square because it is factorable. The other case is that what if the stuff inside the square root is not a perfect square? So let's say it was 60 or 50 or 10 or 15. All right, there's lots of them that are not perfect squares. If the part in the square root is like this, then it's going to mean you're going to have two irrational solutions. The difference, irrational and rational, just means that rational means that the answers will be whole numbers or fractions. Irrational means that the decimal is going to go on forever. So if I'm just going to type in a random one here. Oh, actually, this one was rational. The discriminant was equal to 9, and the answers were fractions. They were whole numbers. And it's also factorable. That was kind of crazy that I just randomly guessed that. Here the discriminant is 17, and that is not a perfect square. So the answers here are these long decimals that never repeat and they go on forever. So if it's irrational roots, that means that it is not factorable. Okay, that's enough.